So here we're doing our range test with the NRF52 development kit. We have two boards here, Alpha and Beta. Alpha is going to be our non-connected advertiser, and to make this the advertiser, we press button 3 on the board twice. LED 1 will now blink fast. Now we connect the power to the Beta board. So in order to make this the scanner, we press button 4 once. As before, LED 1 will flash. So we have both LEDs flashing, and we can see the scan request with the RSSI, which is currently hovering around 20 to 25 dB, or minus 22 to minus 25 dB. So now, with regard to our range test, we're in a shopping centre where we have quite a built-up environment and a willing volunteer. So Pete, do you want to now walk away? One thing to add, that we're using the onboard antenna, and we'll lose about 3 or 4 dB if we don't have the antennas facing one another. But for this test, because we're using the plus 8 dBm output, the maximum output of the device, we'll look at the range and do some range measurements in this sort of non-ideal state. So Pete, what will happen on your board as you walk away? That LED will fail to light once it's lost the connectable advertising. So basically, we're using this as the scanner, and the Alpha board is advertising. So once the scanner fails to receive a packet, that light will extinguish. So okay. Now, if you want to walk away and see how far you can get. Now we've pressed button number 4, and we should see that LED 1 is now lit. So we're now doing using the coded PHY on both boards. So on the Beta board, Pete's holding, and you see that LED 1 is flashing. So now, Pete, if you walk away, yeah, and then we can compare. Yeah. Second instance, we used the coded PHY, and we improved the range by about 10 metres. But as Pete observed, we walked through a large metal doorway that entered into the shopping centre. So now we're just going to continue with the coded PHY, but Pete's going to walk around the shopping centre, stay inside, and see if we can increase the range or compare the range to the original coded PHY test. So now we've moved to an open space. We're in open parkland, and we're going to just test the range for the non-coded PHY. Again, this is the 8 dBm output as opposed to 0 dBm. So what we'll do is we'll set the advertiser to the Alpha board. So we'll double press this, and then we're starting to advertise. On the receiver board, or effectively the scanner, sorry, we'll press button 4, and then we should see LED 1 flashing on both boards as before. So now if Pete walks away, board we can test the distance until his LED's extinguished, and that will give us the maximum range. As you can see, we've been looking at the RSSI, so we're hovering around late 60s. So I'd estimate Peter's probably about 100 metres away, and we can still see that the RSSI is fluctuating, but probably around the minus 70 dB mark. We will actually be able to see a RSSI hopefully in the low to mid 90s, so I think there's a good chance that Pete's going to get to the end of this field and we're still going to be receiving those advertising packets from the scanner. I'm not sure if you can still see him, but he's approaching the end of the field. And we're still receiving those scan requests from the beta device. The RSSI is still around this minus 70 dB mark, high 60s, 70 dB. Peter's now disappeared into the trees, so we'll see how far he can get. As we see now, the RSSI is in the mid to high 70s. We're now looking at possibly mid 80s RSSI. I'm still flashing on alpha board. We're now in the high 90s, sorry, in the high 80s, early 90s at times. Now sort of see some of the scan requests slowing down slightly as some of them are lost. We're still fluctuating between high 80s and occasionally 90, minus 91 dBm. And again, this is the 1 megabit per second PHY.